Hello, everyone, and welcome back to the Security Hall. I'm really excited about this next presentation that we have, and we have the wonderful Ederson Brilhante with us, who's going to be diving through his presentation of building secure and flexible multi-cloud images with multi-boot mode, a comprehensive CI/CD approach. So Ederson is an accomplished SRE tech lead at Cisco. He's coming to us from the wonderful city of Krakow, one of my favorite cities, but I believe that is not originally where he is from. But to give you a full rundown of himself, no one is better than Ederson. So Ederson, I'm going to leave it over to you to take it away. And just before you do, a friendly reminder to all of our attendees here to please ask questions if you have them. You can do it in the chat or at the top of your page. There's a Q&A button. We will be monitoring them. So this is your opportunity to ask Ederson questions directly. We'll cover them at the end. So Ederson, I'm going to leave it over to you.
Thank you. So let's start to present myself. So although I live in Poland, I am originally from Brazil. I have 70 years of IT, and my main experience is being a developer specialist with focus on infra and cloud automation. In this session, we will see about our approach on building different image for different clouds in an environment that we need to have security and different stage of building. To start this presentation, I'd like to give you an overview of CI/CD in general, so we can go later to our approach. So CI stands by continuous integration. It's a place or a system that you want to have automated builds, automated testing, early detections, code quality. So this is where you want to have this kind of system. And for CD, can be continuous delivery or continuous deployment. Depends which kind of product you have. If you have an API, a system that is run 24/7, it goes with CI/CD. You could go with deployment. So you commit, you push, and you generate a build and you deploy immediately. So that's how you can have. In our case, the product that I support is not a system, but an artifact or a file or a binary that goes to the customer. So then we apply continuous delivery. We build, we test, and we make available to be deployed by the customer. So CI/CD is good for reliability. You expect frequent updates. You want to find fast bugs and fix. You want a custom user experience, privacy and security, have transparency. So you want to see what is happening, the logs, and you want to be available. So you need the system to be available anytime you want to have your product within version. In our context, we have a product that is side of Cisco, so is a research connector. So research connector is a product inside a product. So Cisco has security access suite that allows the customer to have the whole network secured and make his own client to access his own private app in the way that's secure. So in our case, we have this research connector deployed the same data center as the private app, and between his own user and the private app, we have the secured access suite and the research connector that's applicable product between the private app and the security network. So that's why we need to support multi-cloud, because we need to be where the customer is. So if the customer has the app deployed in on-prem, we must have and support the on-prem. If the customer is in AWS or in another cloud, same thing. We need to support a VM that's going to be deployed in that environment. multi-boot mode because we want to secure different type of boot modes, like secured boot mode with UEFI, TPM in the future, and local builds. We need to have disabled those options for troubleshooting and debugging, and we need to use multi-stage build strategy. Our requirements and regulations and government regulations demands that we need to harden image, and we also have internal a way of doing. So we have a harden where we install and configure whatever is necessary to have a healthy image used for products and for internal builds. For example, our runners use the hardened image. After the image is hardened, we create the baseline product. So we install partition, we create partitions, we install OS upgrades and other configuration that made the base product available for different boot modes. And then we have also a code overlap in the main times. So some parts of the code are individually by the cloud or by the boot mode, but a big portion of the code has overlap. So we share the same code across different type of image. This is one way is good because it's less copy paste. Another way is bad. Not bad, it's a challenge, I'd say, because if you change one line, it can potentially break everything because then you need to test everything. So that's our context, and that's how we're using this context we came with our approach. So our approach, because we are using GitHub to host our code, we decide to use GitHub Actions. So GitHub Actions is a CI/CD that's supported natively by GitHub. Instead to use Travis or Jenkins or other stuff, in our team we use GitHub Action. And as I told you, we have different build stage. So we have hardened base image and the final product in our case. So, and we use Packer scripts. So Packer scripts is a infrastructure code solution that is made by HashiCorp company. Same with Terraform. Terraform we use to deploy our image, the result of the pipeline, in the environment test. So we deploy if everything that's necessary to support that that image, and we run a bunch of tests using Ansible files. The same Ansible, not the same files, but the same stack we use to build and test. So we have a bunch of Ansible roles that describe how to build the image, what should be installed, how, and how should be tested. And we need a regression test. As I told you, one line in any part of this infrastructure code, in GitHub Actions, in the Packer, in the Terraform, in the Ansible, anything, or even in the software that we are building can change. The OS upgrades, the software that Cisco creates to make the product can be changed. So that's the regression test. Every time you change anything, and you need to test against everything because we have a good portion shared across different image. The structure that we use was to separate in different repos. Instead of have one mono repo with everything, we thought it was a good idea to have one repo with hardened image that can be used for the product, but to other things. So other products that we need, or other deployments, or the GitHub runners where you run the builds. So everything is using this harden. Then we have the product base image. That is not the final image, but the image where we run OSP grades, we create partition and other parts that make a baseline to create a product, the resource connector product. Then we have the final image product that is only receiving a pin version. So where we have the image version pinned with the Cisco software proprietary pinned and connect, and another software that makes part of the resource connect is pinned. So we can reproduce the same build over and over. Because if you're not changing the infrastructure code and we are changing the versions, it always generates the same build over and over. And we need that for audit reasons. So we need to guarantee, and if a person comes or a regulation or some reason comes and say, what is inside of this image? How you can prove that this is a software that you have inside this binary? That's how we prove, because it always generates the same binary over and over. And then we have the tester suite. This is the repo we have a lot of tests: integration tests, sanity tests, performance tests, soaking tests, longevity tests, and many other tests that guarantee in different stages that our product healthy, is safe, and also has no performance degradation between upgrade versions. For the product, the builder suite structure, that in our case we have three repos, they share a similar structure. So it's easier to the developer maintain. So we are trying to keep the same format. It's not the same code, but the same format structure. So when the developer reads, or the SRE reads, it's easier. Okay, the same contract has the same GitHub idea of GitHub reusable workflows, GitHub composite actions. I'm not going to details what exactly is GitHub because we don't have much time to go deeper on that. But reusable workflows are the way how you can reuse a portion of code that run your job. So you have a job that does something, for example, build, and this job is inside of the workflow. And you can, when you call to different reasons, when you create a PR, when another job wants to reuse this, so this is how you can use reusable workflows. And composite actions, I can call as basically a function, because it has an input, output, may have input and output, and internally what does is not concerned to outside of the world. It can be self-contained. And each repo has a common Ansible file. So for build the product base, it has the same Ansible files that we build for VMware, Azure, AWS, and so on, and other clouds that we support today and we may support in the future. Same for the hardened, same for the final product. And we have the Packer scripts that give us the ability to create image for different clouds, because support different plugins, and possibility to different build modes. And because it's infrastructure code, we can know when something changes, and we can track back and have version infrastructure code that we can compare why the build start to fail. And each repo has a file dependency version. So the final version, the final image, we have a file that describes what's the base image, what's the Cisco proprietary version. So version software A, version 100, software B, 102, software C, 200, and so on and so on. So we describe what's the dependency per different boot mode and for a different cloud provider. Same, of course, with hardened and the base image. In the base image, we don't have Cisco proprietary, so we just describe it and other software that we decide to pin. Same for the seed image or the hardened that we have. And in the test suite, we have also GitHub Actions, GitHub Rails workflows. In this case, we don't use Packer, we use Terraform, because we don't want to build, but we want to deploy one environment. We want to set up environment, run a bunch of tests, guarantee it's passive, and later we tear down this environment. So we have ephemeral deployments for each test, for each image and cloud provider. And we test using Ansible files. So we have a lot of Ansible roles, and each role has a lot of Ansible tests, where we describe something to check inside the VM that was booted using the image that we built. So just a simple case here. For example, the product needs to create a file, and the file needs to contain one specific format inside this file. So, and we need to guarantee that is happening. That guarantees that the software is working, because as a configuration file is important to the software. So one task could be to make SSH to the machine, check if the file exists, read the file, and compare the format. And if the file has the proper format and the proper context, it's passing. Otherwise, it's failed. If it failed the test and says, okay, that image is not with the proper build, and we're not going to the next stage. That will be a gatekeeper. So the developer or the SRE needs to fix what is breaking the build. Not the build, but breaking the product past to a health stage. And why this step? As I told you, I am using GitHub because we store our code in GitHub. And the native way of using GitHub is GitHub Actions. So we don't use Jenkins or whatever other thing in our team. We thought this is good because it empowers the developers, has efficient CI/CD pipelines. Of course, has the pros and cons if you compare with Jenkins and other CI/CD. So every system has its goods and bads, and you have to make bypass when you find something that is not good as you'd like, or create issue or request for improvements to the GitHub company. So GitHub is made using YAML files and is customized. You can create your own workflows or even your own actions that can be shared with other developers, other companies. If you want to go to open source, you can create your own action, and other folks around the world can use your action. Has seamless integration with GitHub and can be used for everything, mostly. You can build, you can test, you can deploy, everything in one place. You don't need to have one build in one system, another testing another system. Everything can be done in one way because it's easily to be integrated. You can use external plugins. So very nice to use and easier to maintain. As I told you, easy to customize, so you can create your own extension. So in our case, we create extensions for building, testing, and deployment in the lab, and covers, if not everything, almost all aspects of the SDLD, software development lifecycle. And we use Terraform. Terraform is infra as a code, as I told you, is created by HashiCorp. There was a fork. Now there are the HashiCorp version and the open source by the Linux Foundation. But anyway, the Terraform, the idea is to have infra as a code that defines the infra and has consistency, so you can deploy the same infra over and over. So you can guarantee that the same deployment is occurring over the time. So we need to guarantee the same variable over different builds. We need to support different boot clouds, as I told you, because our product must be deployed where the customer is. So the customer has the data center, whatever it is, and they have the app, and they need to have the resource connector deployed in the data center, regardless of the environment. And that's why you need to have a plugin, or in this case, Terraform, that allows us to deploy in our place that we need to be. We have an order, so we need to deploy the machine. We need to deploy the infra, let's say the subnet, then the VM. Then we need to register the VM to the proper APIs. We need to run the test. So it has order. So Terraform guarantees this order. And this is how you can guarantee that something will not be created before and mess your test. Has modularity, so you can reuse components in other components. So in case, for example, we need to register API, we don't need to create a register API for each environment. We have a modular that registers API, and we just call when we want to deploy in AWS, when we want to call in Azure, or in another cloud. When deploying, you have a state management. So when you run the Terraform, it will create a state file where locally you can place in the S3 bucket, for example, and then when is deploying, it will save the state there. So if it fails, it will save what was created and what was not created will not be saved. It keeps the state. So if you run again, you will try to continue why it started. If it wants to destroy, if it was 100% completed or partially completed, will destroy what was deployed. So it's easier to make a cleanup. So you don't need to care about what, okay, I need to make a guess what was clean up, make a lot of guess in the using, for example, AWS CLI. You don't need to do that. Terraform will do that for you. And because has a large community system, integrates with many services and different cloud providers. Same with Packer, but Packer is good to create image with parallelization and has other plugins. For example, if you want to build a Camo image, has a Camo plugin. If you want to do other type of builds, has a lot of Packer plugins to build. So we use to build and have quickly builds, support different builds, and be able to integrate with other toolings. So we use Packer to build, and we call the Ansible to make the configuration inside the image that's being built. For security, we can we can use Trusted Source. Has a community, so active community, many plugins. You can even create your own plugin, same with Terraform. If there's some plugin that is not available, is made in Go. And same as Terraform, is immutable reference, so you can create consistent image. So if there's nothing changed in the OS or in the code, it will create the same result over and over. So give us consistency, and it's important for audit in our case. And Ansible, because it's agentless, so it's not necessary to install anything inside of the machine. We don't want that. So we just need to boot the machine. Then this happen when you try to build. Then it's available the SSH. Then you run your playbooks as a bash commands. And this is declared as YAML files. So it's human readable. It's easier to read, maintain, add, as a lot of plugins. So you can even use, for example, AWS. You may use AWS CLI, but instead to use the AWS CLI, you could use the plugin for AWS, same for Azure and other cloud providers. So it's a native way of using Ansible. Is extendable. So you can use plugins for other developers, for other companies, or you can create your plugin, and you can use locally, or you can even put in a open source repository that's called Galaxy. It has a larger community in this Ansible community, and as Packer has integration, so can be easily integrated with other toolings. I'll explain now about our workflows. So this is our workflow. We have a hardened image. Then the hardened image will produce a base image using as hardened as a base image as input. And then with the product base image, we can create different boot modes as we want. So BIOS, security boot with UF, TPM, whatever the type of boot mode we want, if the cloud provider supports, is available. So we can have different boot modes for different cloud providers as we want or as we need. Here we can see how it looks like when we extend to different cloud providers. So single cloud providers will have a hardened image. So for AWS, we have a MI hardened image. For Azure, we have image in Azure Cloud. So and so on for other clouds. For them, the hardened image, we create the basic product in that cloud provider. So we have a MI for For the base, same for Azure, and so on and so on. And as I told you, so it will create its own image in that cloud provider for different boot. We are not sharing the same image across all our cloud providers, although we could do it. For example, we could build some VMDK file and then import to AWS. But this, when you import VMDK, is insert some things that you don't want. So this guarantee that we are using the cloud native way. So this is the recommended way by the cloud the cloud provider. So we are using the recommendation from the cloud provider. So build in the way that the cloud is saying. And for testing pipeline, we are using the same flow, regardless the boot mode and the cloud. We deploy the infra and the VM based on the requirements on that environment in that cloud. We run a bunch of tests that currently the VM is healthy, is passing with everything, the files there, the software, everything's running as supposed to do it. Then if it fails, we will fail, but if it's passed, it pass, and after that, it tears down. If it fails, we'll be a gatekeeper and not allowed to go to the next stage. That's more testing or allowing to run to go to the customer deployment. Here, a full pipeline. How it looks like when we have a job that triggers the harden, that triggers the base, that triggers the product, and run the test, and so on and so on. So individual builds, they can run in parallel. So we are not making one gatekeeper than another in the testing, in the build. So this gives us very freedom to increase more providers, more boot modes without increasing the time of the build. So if it takes, for example, 1 hour to build everything, increasing another provider, if the build time is similar, it's still 1 hour to build. It will not be 2 hours because we add something new. I will give an example how we use for regression tests. As I told you, we have a bunch of portion of the code that is shared across different builds. And here, one case, user changes shared Ansible test and creates a PR that wants to change. But this change can break because we are changing one test that builds the image. So you want to change something that you are thinking in AWS. And indirectly, you may break something for VMware. But how do you know if you're not testing everything? And we have different stage builds, and so everything can break in any part of the building or testing. So we need to guarantee that every new change is not creating any problem to testing or to the product itself. So in this case, we build temporary image for the harden. With this temporary image, we create a build image for base image using as input this temp seed image. Then we create the final image, same with the temporary base image. Then we deploy, we run tests, and we tear down. So if everything is passing in that boot mode, in that cloud provider, that means that change is health and safe for that change to that image. And we do the same for every single cloud providers and boot mode that we support, guaranteeing that, okay, that change is not affected. So when everything's passing, we allow the merge. When we merge, then we create the promotion pipeline. We use the promotion pipeline job. So here is an example, not from this harden, but from the base image, from the product final image. Sorry. So we have file dependency files with the base image, with the software that Cisco creates, the NConnect, and other software that's proprietary, and we create a PR. And a job, we will understand, okay, I'm changing only for AWS. Anything else will be supposed to be the same. So we make a GIF and say, okay, I only have to build for AWS. I only have to test for AWS. The other things are not changing. It's the same. So you create a real image in this PR promotion. You deploy machines, we run and tear down if everything passing, what was changing in this PR. You allow the merge, run the sorting test, vulnerability scans, and so on and so on. Many other steps until you have ready for the GA to allow to the customer to use. If everything in this promotion pipeline fails, is blocked, you're not allowing to go to the next and further process. So we back to the development, we have to fix and go again and again to the process until we have everything sorted out and ready to be used in production for the customer. So this is the final image. For the seed and the base image, we have similar. In the product, in the final, we have specificities that we need to use peanut versions. That we can guarantee that if we change the infrastructure code, it's peanut. If we change the base image, it's peanut. If we change any Cisco, it's peanut. So we have a version file with everything. So if you run again and again, it always gives the same image over and over. For the image, the base image, where we install partitions and we install software upgrades, that may change. So the infrastructure code can be the same, but if you run today or run tomorrow, it may change the result image because maybe there was an upstream update in some software, Linux package, or something happened, a CV was fixed, and then so the base image will create a different result over and over. But we create a new base image version that will be used in the final image. So that's how we can guarantee, okay, new CV fixed, new base image, new PR to the final image. So the dev builds. We have dev builds, VM debug, and manual tests to allow developers to deploy without taking much effort in deploying and test. So we have case that developers is changing some Cisco proprietary code, and he wants to see how it's look like in the final image. So it can create customized dev build. It can pass what's the seed, what's the base, and what's the customer version, the software that builds, or even products that's being on stage or in testing yet. So can be created and used for manual deployments or any other development use case. So give us the freedom and help developers to have a fast feedback on the software. We also allow manual tests. So because we need to support different modes, different environments, could be is a toil to developers to know all environments, to know how to deploy, how to test. So the developer just have to say, I want to deploy in this environment, in this cloud, and using this version. Trigger for me deployment, give me access. So it will deploy, give us a ephemeral VM access via SSH, and the developer change the playbook. And so it's, let's say, adding new use case tests. Using the pipeline could be done. Can be commit and push, but the feedback is too much time. So every time you're fixing, it take a few hours because you have to wait everything to pass. So for a fast feedback in development, it's easier to have one machine you run locally. So if you want to see what is happening, you run again and again, and you can have a fast feedback. And this ephemeral takes the developers decide how much time he needs. So 1 hour, 1 day, 1 week, and the machine will be run. After that, we tear down and delete and remove our environment automatically. I have some code samples. So here is how our GitHub action is structured. We have a .github. This is how you create workflows and actions in GitHub that replace the workflows and the actions. We have a folder with Ansible. We have a folder with Packer. And inside the folder Packer, we have the examples here. I gave just three: AWS, Azure, and VMware. And each a boot mode file, and or it's not necessary to have. For example, in VMware, I just place at one to give an example that it supports different, and it's not necessary to be the same over different clouds. And we have the versions YAML file. So similar in the second column is for the tester. We have also GitHub Actions, we have the workflows, and we have also folders that describe the how you're supposed to do it in each cloud. So for AWS, for Azure, for VMware, how to boot for VMware, how to boot for Azure, tear down, and how to run the test. Because although the code we are trying to use overlapping, there are some specificities on each environment. So for AWS, you need to get the AWS connections. For Azure, you need to do the same, get the resource name and other stuff that we place in secrets or environment variables. So we need to get this data inside of this action, and then we call the test. So we need to. So this is self-contained. All dependencies for each environment or each cloud is self-contained. So it's the same contract. So it has the same input, same output as a function. A signature is the same, but what does inside it doesn't concern. So the developer or the SRE, okay, I want to deploy AWS VM. Okay, just pass the image, pass the what you need to the platform, whatever is the similar inputs, and it will do it. And as in the build, we also have Ansible playbooks where we have the playbooks to run the tests, and we have a callback plugin that will check the result. And if there any ignored, any error, anything that is not passing, it will fail the job and not allow it to go to the next stage in the pipeline that I showed before. The composite action, as I told you, I understand as a function. You can understand as a function because it has a signature with inputs and outputs, and does something internally. And what does internally can be anything. So you can install, you can configure, you can call it external APIs, whatever is inside, so can be called as a function. In this case here, this is a plugin, not plugin, action to build a base image for AWS. So we pass what the version image that we want to create for that, what's the seed or the harden, and what's the output, the image that we are returning from this build. Has a bunch of steps, getting the permissions, installing any plugins that's necessary to build this image. Then we run the Packer. So you can see, so we pass environment variables, and we call Packer, and Packer needs to initialize the Packer, and the validate and build, and this will create the build. This will boot the machine in AWS. Then the build will internally call the Ansible to install and configure the machine. Then after run everything that you should, Packer will automatically tear down the VM and create a snapshot, and then from the snapshot you create MI. So similar happens with other cloud providers. It's not the same API, it's not the same way. This is how that cloud provider does. But the signature is the same. So we have a Packer in it and some file that does something internally. So this is the signatures that we have. And reusable flows. Similar with actions, also can be intended as a function where you have inputs and outputs. You pass the input that is internally used, and instead to be just steps, this is job. So you have, and each job is executed in a different runner, is a different machine. So you can have a builder, you can have a test in the same workflow, and the build runs first, and after the build is done, you can say, okay, wait the build and run the test. So You have also internally what you need. In this case, we call the pipeline that's agnostic. We pass uh, the version, the platform, and then with the platform, we call the proper action, as you can see in the last block in the second column, where we call the proper action to the platform, and we pass image and the hardened or the seed image. For reusing workflows, I told you that based in what you change in the version files, we describe, we create, we build exactly what was changed. So if you're changing only for one boot mode or one cloud provider, it don't make sense to create a new product because the same image from the last build is the same. We are creating the same result over and over. So that's why we are using version. So based in the discovery of these diffs, we will make a matrix, and with the matrix, we will trigger the proper builds. Here is the jobs after the matrix that we created. GitHub has a matrix strategy. So you can use option, name and matrix, but with reusable workflows where you can have a job, then with an error, with another job, and so on and so on. So we have a long workflows. Is not very helpful in the interface. It will make one unique block and put one job above another. So you don't have in the interface the arrows. Building different clouds in a long pipeline, we need to have an interface that allows the developer, the SRE, to identify the issue easily. So that's why it's hard coded the pipeline we support, but we use this conditional if. So if it was generated by the matrix, that means should be triggered. If not, it will be ignored and skip it. So here you can see. Here's how you're using in our approach. But if you're using the matrix, that is how GitHub today supports. It is only one block. You see instead these beautiful arrows, just one job above another, and you don't know exactly what's the builds, what's the testing, because it's only one thing. So there are an issue that people are waiting for this to be improved, but until it's not improved, we choose to use this approach. So here with the bug, so the teardown we deploy the machine. Well, in this case, the developer asked for 1 hour, so run 1 hour, gave it access via SSH, and tear down after 1 hour automatically. So we have a clean environment. The user or the developer don't need to have access to all cloud provider labs and everything. Only access to the machine via SSH and done. Reduce access to environments, access to clouds, anything that reducing the risk anyway to create message from developer or creating things that should be created in that lab. Some crucial takeaways. As I told you, so developers don't need to deploy the thermal infra themselves. Access to a specific, they just need to say, I want to deploy this VM in that environment. Please do it for me, and done. It will be done. Can be used in the pipeline. Can be used for troubleshooting. In worst case scenario that we saw, all stages and builds takes about 3 hours to be tested build and ready to the next stage. That is performance test, load test. So, but this takes time. But the build, like we have, that's the image that is bootable and is working, is about 3 hours. And so if you have any CV fix said that we need to fix urgently, we do it in 3 hours. Have an image that it can be fix it. If it's a medium, like a hot fix, we can do it, and done. We are fixing something. We can easily to add more cloud providers. It's not affecting the time, so we don't need to hire more people to support the infra, hire more developers to test and boot be a I don't know a full QA team, because the pipeline serves as this purpose. So we just need to add more providers as much the product needs to support. We are using infra as a code principle along with final version. So this allows us to find bugs faster. So if we introduce bugs, we know because it start to break. If something is start to break, could be not because of version, but for something in the OS package upgrade. So we can determine where it start to have a problem and try to fix as much as possible. And the pipeline is very modular. So has different cloud providers, but it's not a problem because all dependencies, all logic is self-contained in an action, in a workflow. So this gives us freedom to extend and add more cloud providers easily without any problem or breaking anything that's working. I have some links here. So if you want to learn about this stack that you don't know yet, so here can give you I started. So about raise workflows, actions, how to trigger workflows, about GitHub, about Terraform, Packer, and Ansible. And here is my so if you want to send me a DM in the LinkedIn to get more information about the pipeline, because this was very short talk. So if you want to see, you can access my LinkedIn and my GitHub. And the idea that we are trying to open source this code as soon as fast. We are going to a process to. So you're not seeing the product, but the workflows, the structure, the architecture will be, we want to open source. So we are in a process to open source, and you can see as a vanilla version how to do the same regardless of your product. So if you have to deploy something similar with different stage or just one boot, doesn't matter. You could use the same architecture that we use. So now we are open to question and answers.
Awesome. Thank you so much, Ederson. So to the people online, please add any questions that you have into the chat or into the Q&A tab. We'll be monitoring that. We are a little bit over time, so we will try to be brief. But Ederson, I'll kick things off. I have a question here. That was an incredibly insightful presentation. One, I'm gonna have to admit, I'm gonna have to go back through some of the materials that you shared to fully wrap my head around everything. But I was curious: are there any kind of common mistakes that you see people making with their CI/CD pipelines and building their images in areas where that create security holes that can easily kind of be fixed based on what you shared?
Yes. So our approach is to fix and reduce the toil to have a product, because we need to support different clouds, boot modes, and we share the code with different things. So we try to pin the version. So the pinning the versions is crucial to our case, because we need to guarantee that, okay, we are using a new AnyConnect version alongside with other softwares that Cisco creates to make this product. So we need to guarantee that the software that we created ourselves is not creating any security issues to the customer, because this is be deployed to the customer. So when we have this final version and we test against different sweep tester vulnerability scans, this allows us to fix this. Or when say we are updating the OS package. This is not our part. This is from the supplier, from the Linux package that we don't have management. but we need to guarantee that we are not creating any problem, because we are using something from open source can be included. No, I don't know. Let's say a new core version that injects something that's some vulnerability, some access to the machine, to the customer. So we need to guarantee that anything that we inject from our part or from the supplier, we need to guarantee testing that will not break, that the software will work, has no performance degradation, but also internally scans. So we use internal scans, we scan the VM, we scan the image, that everything's fine. So that's how we can guarantee that not only mistakes by the developer, but from the Linux community that we use as well.
Yeah.
Does answer your question? Or
yeah, absolutely. I think we have to unfortunately wrap up here. But if you have questions for us, and I'm sure that you can reach out to him. I hope so. Anyway, his details are on the screen to follow him on GitHub.
Yeah.
To follow him on LinkedIn. That would be great. Ederson, I just want to say thank you so much for sharing your knowledge here, sharing the great work that you're doing at Cisco. Wishing you all the best, and I hope you enjoy the rest of the conference that you have with us.
Thank you. Yeah. Bye bye.